So this is the second part of lesson 18, and it actually doesn't deal with projectiles at an angle, but it is all part of projectile motion and has a common problem that you see. So basically what we're going to do here is take a ball and throw it up, and it's going to go over a cliff and land down there. So really, in strict technical definition, it's just a vertical, even though you can see it's got a little bit of horizontal. That horizontal motion is negligible. It doesn't take in, it doesn't, since it's mutually independent, the vertical component, it doesn't factor into our equation. So we treat this as just a vertical, just throwing a ball up in the air and it's coming down. It's just coming down off a cliff. So you've got this additional factor to worry about. So what have we got in this problem? The question is, I throw a ball off a cliff, let's say at 20, the initial velocity is 20 meters per second, and the cliff is 30 meters high. And the question is, how long will it take to hit the ground? So we treat it as a vertical question, and we have the initial velocity. We have the acceleration due to gravity. We have the displacement. Now, just acknowledge that the displacement is actually this distance here, because the displacement is from where it started to where it ended. So blue is the distance it traveled, but the green is the displacement. We want to write the displacement. So that is going to be, since it's going down, negative 30 meters. And we want to find the time. All right, so you look at that and you go, oh, well, we've got three variables. We want the fourth. We have a formula that relates them all. There it is. But here is that one time we're solving for t. And here's the one time, or the example, where t is not zero, so therefore this part doesn't cancel out. And if you try and rearrange this formula for t, you're going to get into some serious problems. In other words, you can't do it right now with the knowledge that we have. So you can't solve this for t. And so we're going to have to do this. And so let's plug in the numbers so you can actually see what happens. There, so there we plugged in the numbers and we're stuck at this point. Now there is a way that you can solve this on your graphing calculator, which I will show you because you're gonna have to know this for 20-1 anyway. So you might as well get a head start on that, and the graphing calculator is very powerful in this way. But for now, let's just solve it using kinematics. And we're gonna have to solve it in multiple steps. So what we're gonna have to do is we're gonna have to calculate this displacement, the vertical displacement, and then, in other words, from here to the top, and then we're gonna have to calculate how long it takes to do that, and then we're gonna have to take how long it is to do this part, and then add them together. So it's really a 3 or 4 step process. So we'll start with the displacement, and this is all vertical component. So step 1 is the d to the top. Right, and the information that we're going to use for that one is di is 20, F, since it's the top, is going to be 0, acceleration due to gravity, negative 9.81, and we're trying to find the displacement. Right, so we have our kinematics equation for that. And just in the interest of time, I'm going to tell you that the answer is 20.39 meters. Okay, so this displacement here, 20.39. In other words, when he gets to the top, it's going to have to fall 50.39 meters down to get to the bottom. Okay, so now let's find out how much time it takes to go from its starting point just to the top. So step Step 2, we want to find out the time to the top. Let's write that actually. Time to the top. So we want to know time. We have the initial velocity. We have the final velocity at the top. Again, it's 20, and we have acceleration due to gravity.
Don't forget to exchange your lockdown kits and your red binders. You will need to add your cross-list to your folders as well.
And we have a formula that relates all those. So therefore, T equals VF minus VI over A, and it turns out that T for this one turns out to be 2.03. Put a box around that. So 2.03 seconds to get to the top. Now we need to calculate how long does it take to get from the top to the bottom. And again, this is made easier by the fact that now we're going to say the initial velocity is 0. Acceleration due to gravity, 9.81, and we have the displacement now. So step 3 is time from top to time from the top to the bottom. The initial velocity, 0. Acceleration due to gravity, -9.81 meters per second squared. The displacement now is going to be negative 50.39. And where did that number come from? Well, we calculated the displacement up to the highest point, and then there's another 30 meters down here. So it's the total distance that has to travel from the top, which is 20.39 plus 30. That's how we got the negative 50.39, because it's coming down, and we're trying to calculate T. Now for this one, we're back to our original formula. But this time, since VI is 0, this cancels out. And we can solve for T. And we end up getting 3.205 seconds. And then the last step, step 4, is to just add the 2 times. Add the times, so that would be 3.205 plus 2.03, and that gives us 5.24 seconds. That's the answer to the question. All right, so you can do it that way, and that's fantastic. It's kind of time consuming, but it gets you there, and it gets you through all those physics principles that we've learned. Now let's, you don't have to watch this next part if you don't want to, but if you want to get a head start on 20-1, then quadratic functions, parabolas, then we can solve this using our graphing calculator. And what we're going to do, you're probably not going to get this right away, but at least you'll be exposed to it. So when you do it in 20-1, you go, oh, I kind of remember that. It's kind of neat. Where's my calculator? So open up our calculator. And what we're going to do is we are going to take this equation right here. So let's actually rewrite that so it's a little not so messy. Okay, I think we're still recording. Here we go. So we're going to write that equation out. Negative 30 equals, what was it, 20t plus 1/2 a t squared. And I'm just going to replace the t's with x. So we're into the math world now. X squared. And then I'm going to move the 30 over to the other side just so I get 0 over here. Plus 30. And what I'm going to do now is I'm going to put this into my graphing calculator. So you get out your graphing calculator, and here we go. Close. And here's what I'm doing. Let's clear all that. I'm going to press y equals. You're going to have to do this a million times. I'm going to clear that. And I'm going to clear that. And I'm going to put that equation into y1. So that equation was 20x plus bracket 0.5 times negative 9.81 and the bracket, and then x, there's your x, and then squared, and then it was plus 30. Okay, and that's going to give me a parabola. When I press graph, it's going to give me a parabola. Now you're going to have to change your width. When I press graph, here's what's going to happen. Okay, oh my gosh, it actually gave me the parabola right away. That's cool. That's super cool. So there it is. That is the motion. That's a visual representation of the motion of this projectile. And you can see, so the x-axis is time, and the y-axis is displacement, right? Because we replaced the t's with x's, right? So the x-axis, and the d was the y-axis, and that's going to be displacement. So now we can find out the amount of time is the x-intercept on this graph here. The x-intercept on this graph. Now I'm going to go into y equals, and again, you'll understand this when you do 20-1. It's going to be a little much for you right now. I'm just going to put 0 in there. It just helps me get the answer. You'll understand why later on. And then I'm press graph. Now, all I want to find is the intersection point between this red and this blue. So I go second function, trace, 5 is intersect, and then I press enter 3 times. It says first curve, you see the cursor on the first curve. Second curve, you see the cursor on the second curve, the red line. Press enter, and then it says guess. And oh, okay, that was an epic fail because I actually want this point over here. So I'm going to try it again. Second, trace, intersect. And this time I'm going to move the cursor so it's closer to the intersection point. There we go. If we get on this side, this will work this time. Enter, enter, guess, enter, and there we go. It gives me my answer right away, 5.24 seconds. Okay, so that's how you can solve it on the graphing calculator, and you can watch this video over and over again if you want to figure out how to do that. Otherwise, just stick to this method here. You will be doing graphing calculator stuff in 20-1 and lots in 30. Bye for now.